Hello guys, in today's video I want to show you the process of creating this animation, which I did it a while ago. So first let's see the result. Okay, so in this animation, as you can see, we have lots of cool things happening here. For example, like deforming the walls, falling down objects. Here objects have no gravity. Again, they have gravity. Okay. Before starting the tutorial, I want to thank you guys for supporting me in any case and for reaching the 1K subscriber on my YouTube channel. In my YouTube channel, you can find my animations of the projects and some free tutorials. And if you want to support me more, you can be a member of my Patreon channel. You can find my Patreon channel link in the description, and you can find all the project files of my tutorials here, exclusive content, extra tutorials with Tyflow, modeling, rendering, lighting, tips and tricks, and lots of cool stuff here. And you can support here. Be sure to check the link in the description. Let's jump inside 3ds Max and see how we can create this kind of animations at 3D. Okay, so as you can see that I have already some layers. Layering is very important for this kind of animation, and you can see that I have different layers like camera, light, main objects, Tyflow object, and other objects that I used in Tyflow. Let's start with the first animated object. As you can see in this animation, the first animated object is the wall. The wall is the starter of the collision for the Tyflow objects. And we have here the ceiling fan. Okay. Animated of the wall is very simple. If I hide the other layers, you can see that I have animated these walls. If I play it, it is very simple. I just add a FFT modifier on the wall. Let's see how we can animate it. For example, I will duplicate it and delete this FFT modifier. And delete the animated keyframe. Okay, so you can see that we have no animation here in this object. I just add the FFT 2x2 and click the vertices here of the FFT control points and turn on the OT key. For example, after 50 frame, it will be deformed to here. Also here, the right side of the wall. Again, after 3 frames, it will get back like this. And I can repeat it by pressing shift and drag it to the other side. Okay, if I play the animation, you can see that we have the animated wall here. In my animation, you can see that we have curtains attached to the animation. It has the same FFT modifier here and here. All of the objects, like this window, this curtain, another curtain, and this object on the ceiling, lamps, all of them have the same FFT modifier. Even the floor, it has the same FFT modifier. And if I go to the camera view, you can see that all of them have animated with just one FFT modifier. Okay, for the fan, let's see how we can animate this. And let's select this and copy. And then remove the keyframe here. Yes, and I think it was linked to each other. I just select them and unlink them. Unlink selection, select and unlink. Yes, unlinked. And first of all, we need to change the pivot point to the center of the object. Here, go to the pivot point, affect pivot only, and center to the object. Okay. And after that, for example, I need to have 250 frame of animated fan, and just hit N on the keyboard to turn on the auto key, and rotation, right click on it. For example, here set auto key and go to the last frame. I need to have, for example, 2500 degree, for instance, and turn off the auto key. If I play back, you can see that we have animated a fan, but it is the, I think it's, yeah, it's auto tangent. For the fan, yes, it works. It doesn't need to be a linear workflow. And start and accelerate it and then stop. Okay, this is for the fan. It is very simple. And what else? Let's see. Okay, so let's start the Tyflow. How we can make the Tyflow objects here. You can see that I have the main objects, the original objects from the from my model, and as you can see, I optimize all of the objects here as much as I can. Let's see how we can optimize these objects, because these kind of objects causes the very heavy calculation for the Tyflow, and it will be very slow. For example, let's let's optimize one of them. Let's isolate it and copy that, and I think it's group. I just ungroup it. Yeah. I just delete these stars. We can see in the render, and this sphere, as you can see here, if I go to statistics, total plus selection, I can see the segment number, polygon counts here. We have 4,000 polygons. I just use the Pro Optimizer modifier. It is very powerful and it's very handy, and I use almost in all of my works for optimizing the models. Okay, so I check this option, keep textures, to keep my textures for the material, and calculate. Just see here, we have 4,700 polygons. I just reduce to 50% and turn on the wireframe, turn off the wireframe, sorry. 25%, 30%, 40%. But listen guys, this is the very small object, and from, let's see, from here, from this view, it doesn't matter that how much more polygon do we have here. I can reduce it to 25, 20, 10. I think 20 is enough, and just convert it to editable poly. I used my hotkey to convert it to editable poly, or you can use right click and convert to editable poly. Okay, now we have almost 1,000 polygon. This is the optimizing method, or we can optimize these or these. Let's see how we can optimize this complicated object. It has 300,000 polygons. I think I optimized once and reduced the polygons, but let's see, can we optimize it again? Pro Optimizer, and keep textures, calculate. Just reduce it to 50%. We can see that we're losing the details here. We can change to 16, 70, 80. But in this case, I think we can even go furthermore, because it is very far from the camera and we can't see the details. I think I can use 50%. Yep. Or even more. No, 40, I think it's enough. And then convert it to editable poly. And I think you get it, guys. This is the optimization I did with almost all of these objects, small objects here. This method, the Pro Optimizer modifier. It's very useful, so be sure to use to your works. I can use to these objects, these polygons, this sofa, sorry. For example, add Pro Optimizer. Modifier, and turn on the cube texture and calculate, and reduce the percentage to 50%. Here you can see the difference between the original object and the optimized object. Until 50% we have almost no difference. 40, 30, 20, 10, 5. Yeah, now we can see something happening here. 8, 6, 5. I think 5 we can use. In this case we can use this 5%. Okay, you can see the huge difference. It has 82,000 polygons and now we have 7,000 polygons. It's very big difference. Okay, let me add it to Pro Optimizer here. Calculate 10, 5, 6%. Okay, let's delete it and turn it on. Let's delete it again. Also we can use for the other objects here. Or I can copy that and paste it here and do the calculate button here again. Also for these. And press the calculation with 6% of vertex here and do the same. You can use it for curtains, for all of the objects. If you don't have a powerful computer, you have to use this technique because it will increase your render time and increase the calculation time of your Tyflow. And you can see the huge difference between the optimized object and the original object, but almost the same result. Okay, I think that's okay. And yep, even I can optimize this for the curtain. Let me paste and do the calculation. If you turn on the wireframe, you can see that very messy polygons, but if you turned the standard mode, default shading, you can see there's no difference almost. Yep. Also for these, you can see the difference. It has 85,000 polygon, and now with the Pro Optimizer it has 10,000. Okay, so let's turn on the Tyflow. Yes, here. So you can see that I have some tie collection object here for managing my objects. It's nothing special. You can use your tie collection. It's very simple. Just go through the helpers and Tyflow. You can create a tie collection here. For example, I have a bunch of spheres here, spheres and some boxes or some cylinder, and you want to manage your works, you want to manage your objects here. For example, I want to have these spheres into one collection, these boxes into one collection, and these cylinders into another collection. So simply I can use the tie collection and, for example, pick this, pick this, pick this. Now this is the tie collection for the sphere. For example, a sphere, and I can make another tie collection and add this cylinder, add this cylinder, and again. Now I have two collections, one for the sphere and one for the cylinder. Okay, I did this method to my Tyflow objects here. For example, I did this table and objects, put it into one collection, for example, and these small objects, I select them and put them into one separate to another separate tie collection. Also these sofa objects, I select all of them and make them into another tie collection. As you can see here, I have tie collection for table, tie collection for the left wall, I mean this left wall, everything I have here, TV, the bonsai and other things. For collection for sofa, right wall, on the floor, just for the managing my scene. And then we can start creating Tyflow. And let's open up the Tyflow and let's see what do we have here. Honestly, it doesn't have nothing special. It is very simple. And let me explain first. What do we have here? We have first birth object here, and in the birth object I selected all of these tie collection, which I made it before. Tie collection of table for the left wall objects, for the sofa, floors, and right wall. You can see here I select all of them, and be sure to check the inherit from object and the instance material to inherit the materials from the original object. And the render time, let's delete this, and after that I will add a physics shape, physics collision for the collision object. I added lots of objects, for example the floor, walls, ceilings, curtains, and all other objects that I want to have a collision, and then add a force gravity, and I just click on it and put the real world value. This is the real world value, and it may be a different value with your units. I using the generic units, and 1 unit 1 millimeter, and for you it may be different. If you're using centimeter or meter, it will be different value here. And after that, when all the animated objects moving around, like wall, like ceiling, like floors, and they have collision force, and with the gravity they will fall down. If you can see here, the wall will push the objects, and small objects will falling down with this force gravity. And after that I used a time test, a condition operator. It's very simple. You can just click and drag it and add a time test condition operator and tell the Tyflow after 100 frame with the 3 frame variation goes to another event. For example, after 100 frame, let's see here, until 100 frame, yes. Oh, let's turn it on. Go to another event, the second event, and at the another event I just duplicate the physics shape and physics collision again and copy that to this new event here, physics shape and physics collision. And after that I add a gravity force operator, and in this case I add the value of 30, very high value for the gravity, and it's positive gravity, it's not negative. You can see the objects will goes up. It seems that it has no gravity. Let's see in the camera viewport. You can see that objects have no gravity here again. And after that I added another time test condition and I put the value, and I explained the Tyflow. I tell Tyflow that after frame of 150 frame goes to another event, and again I just copy that physics shape and physics collision again, and with the force and the exact real value of the gravity, and that's it. It's very simple. The current scene, it has lots of objects. It is quite heavy, so if we want to test, it will takes lots of time to calculation. So I decide to create another scene, very simple scene, and do this step by step again for better understanding. Okay, so let's turn it off and let's open another 3ds Max, and for example I have my objects here. Let's see, a plane, and maybe 4 meter by 4 meter, and and add some objects. For example, I have some different objects, boxes, spheres, teapot, pyramid, maybe another sphere, another box, okay. I just want to show you the exact workflow which I did in my scene. Okay, so first I made a tie collection here, Tyflow. I need 3 tie collection. For example, one for the teapot, and pick this and this, and another one for the boxes, pick this, and the third one for this mixed object. Okay, and let's create a Tyflow. And open editor. First of all, I make a birth object, and at this birth object I will add these tie collections. Add selected. You can see immediately they begin. Oh, sorry. Let's first move them into the scene. For example, this is the scene. I forgot to move them into the scene. Okay, and again turn it on. And hide all. You can see that we have tie collections here, and just turn them into the physics shape. Physics shape, convex is okay, and let's hide selection. And turn on the Tyflow objects, only Tyflow objects, yeah. And add a collision, physics collision. Pick this, and in my scene I have a ceiling. I just copy that and change the name to ceiling, and add it to the collision object, and then add a force. But before that, let's see the Tyflow setting, and to physics I turn the ground collider and make the default value of the gravity to the default value, and let's see what do we have. First the start, and change the force, the gravity value to, for example, 10. You can see here maybe 5. Here you can see that some of objects will go through the collision. Just go to the setting and increase the time step to 1 second, or maybe more, 1/4. Yeah. To increase the time step, the Tyflow will be more precise for the calculation. Okay, so, and then I need a time test. For example, after 30 frame goes to another event. For example, yeah, you can see they change again. Let's add again the physics shape and physics collision. Hold shift and drag it to copy that here. We have event 1 with this color, and after 30 frame with 3 frame variation goes to the another event, and then we have this. It automatically have the default value of the gravity. And then after, for example, let me add another time test. And after frame, for example, yeah, after 60 frame I can add, let me increase the timeline, maybe 100 frame goes to another event, and again copy this physics shape and physics collision, again add this force, shift drag to copy, again we have this, and maybe more. I can add another time test. Just you can play with it. After, yep, I can add another time test with, for example, 20 frame or 30 frame. Again, we don't have we have gravity again. Okay, let's see what do we have here until now. We have gravity again, no gravity. After that we have gravity and no gravity. Yep. Also we can add some noises to the force. For example, here and here we can have some noises, for example build and wind, maybe in X and Y, 10, 5, no, it's too much, 1 centimeter, And again in the third event, we can have a noise force, maybe 1 centimeter. Also we can add something for example, let's see, for this maybe I can add a rotation operator. Yes. And force 2. Let's decrease it to 2. No, 3. I think 3 is okay. And I can make it bigger. Let's and then we can play it again. And also we can add, for example, more time step here. Yes. Now it's great. I can for example, we can have this kind of wall. Let's see. I can add some wall here. And add them to the physics collision. Add selected here. Also add the wall. Yeah, already they are instances. Yes, they are instances, and if I add the wall here, it will automatically add to others. But here, yes. Okay, so if I zoom in and see the result, you can see here. Yes. Now it's more beautiful. We have first event after .30 frame, it will have gravity, and then after 100 frame, again it has no gravity, and then it will fall down. Also, I can increase the time step here. I can move this here and also this here. Yep. I have to fix this ceiling. Let me fix that. Okay, first event, second event, third event, and the last one. Yeah, that's right. You can see that in a very simple way we make a beautiful effect for the objects. You can see we have first event with no gravity, then go to the another event through the time test condition after some frame, and we have another default gravity. If we use physics shape and physics collision with no force, it will use the default gravity of the Tyflow setting here, and you can see here, yes, the default gravity is checked on. And after that, again, we have no gravity with positive value. It means that we have no gravity. And again, we use time test to send the particles to another event. And for the rendering, you have to just check the birth object and instance material. Check the instance material to inherit from object, and after that we need to add a mesh operator for all of them. Just copy and paste it here. That's it. It can be your sofa, it can be your books, it can be your object in your scene, and you can simply just put this Tyflow setup in your scene and make your animation. And let's back to our scene. Let's see how we can render it. In this case, I am using the Corona render engine, Corona 12. I made this animation with, I think it was the Corona 8 or 9, I think. But anyway, now I'm using Corona 12, and for the lighting, you can see if I turn on the lights, you can see I just have a Corona sun here with this setting, very light intensity 0.05, and with the size of 5, and for the environment scene, I think, yes, here I just use a Corona sky with color corrected nodes. Here it's the Corona sky, simple Corona sky, and color corrected with desaturation value I just desaturated. The reason that why I'm using the Corona Sky, because for the rendering of the animation, Corona Sky is very fast. It's very fast, and it will increase your the speed of your rendering time. And if you are using HDRI, of course you can achieve a better result, but you will have a slower render, and the HDRI will increase your render time. Absolutely. So for example, here as I mentioned before, in birth object, I just check the inherit from object and instance material section to get all the original material from the original objects. Here, let's start IPR rendering. You can see how fast it is. For example, there's frame 0, frame 30. It's rendering very fast. Tyflow works very well. All of the objects have the original material. Frame 50. You can see that in a very high speed we can see the results in corner render. Okay, so that's it guys for today's video. Hope you enjoyed this video. If you like it, please do subscribe to the channel and like, comment your opinion and share it with your friends. Thanks for the watching and take care.